Yes, microphone is working this time. So we are going to start with 4.3 quadratic functions. There's two types of quadratic functions that we're going to take a look at. We have what I consider to be a short form and then a long form. The short form is f of x equals a parentheses x minus h squared plus k. This is also known as like the vertex form because it gives you the vertex, and we'll talk about that here in a moment. And then you have your long form, which is your standard quadratic equation. Try that again. Ax squared plus bx plus c. For this one, you're going to need an additional formula where x equals negative b over 2a. This one gives you the vertex. Vertex just meaning the center. So it really just depends on which one you're going to get is the one that you're going to need to use. The nice part is you only got a 1 in 2 shot. Also, in the CA Formulas website, you have them right here. So this is your short form in your vertex, H and K. And then if we keep going, if you notice here it says vertex again, and you have the actual formula for the vertex. Again, really it just comes down to this negative b over 2a. So let's start some practice this time. So for this one, it wants us to find the vertex, and we lucked out. We get to find the easy one. So f of x equals x minus 4 squared minus 4. And for vertex form, what we're looking for is this h and k. That's going to be the center or the vertex of my parabola. So for us, it is going to be located here and here. With this one, since it's in a set of parentheses, math will hate me for this one, but when we're dealing with quadratics and we have something in parentheses, what we're going to do is just take it out of the parentheses, but we're going to change the sign. So if I look here, I see x minus 4, so a negative 4. When I pull that out, I'm going to say that it is now a positive 4. Just so we can use colors. This is not in parentheses, and so it will just come down as negative 4. And that's our vertex. So we can go through. It already has parentheses for us, so we can just say 4, comma, negative 4. We got it right. If we look at this, it's going to ask how many, find the x-intercepts, if any, express the x-intercepts as ordered pairs. How many x-intercepts does this function have? This one's a little bit further on than what we want, but we could still do this. And in order for us to do that, sorry, I had to sneeze. In order for us to do this, we are going to take this equation, this one, and instead of f of x, or remember this is y, we're going to just change this y to a 0. So, I can't do it that way. Here we go. So, we're going to go 0 equals x minus 4 squared minus 4. And then we're just going to solve for x. So the very first thing, we're going to add 4, add 4. 4 equals x minus 4 squared. In order to get rid of a square, we're going to have to square root. And so on my right side, I'm left with x minus 4 equals the square root of 4. The square root of 4 is 2, but remember that this is a quadratic equation. It has a square in it. So it's not just 2, it's plus or minus 2. Because 2 times 2 is 4, and negative 2 times negative 2 is also 4. Here, create two equations. First one, x minus 4 equals 2. And on the other one, x minus 4 equals negative 2. We are going to freak out because my thing's a little too close. There we go. So now we're going to solve. Add 4, add 4, add 4, add 4. X equals 6, and x equals 2. These are going to be our x-intercepts at the point 6, 0, and at the point 2, 0. Over here, if you notice, it'll say like none, 1, or 2. Since this is a quadratic, you should always either choose none or 2. Well, I know that it's 2 because I got two answers. I got a 6 and a 0, and they're normal numbers. They're real. If, for whatever reason, we would have had to take the square root of negative 4, and thus had plus or minus 2i. Imaginary numbers you cannot graph for us, and so if we get an I up here, we would say none. But because we got two sets of coordinates, we can say 2. The first one is at 6, 0, and the other one is at 2, 0. I tried it again. I don't want to do it again. This one, because I messed up. This is dumb. Be careful on practice. We'll just go through it again though. 0, parentheses, x minus 1 squared minus 4. Add 4. 4 equals x minus 1 squared. Square root plus or minus 2 equals x minus 1. X minus 1 equals 2. X minus 1 equals negative 2. Add 1. X equals 3. X equals negative 1. So I have two sets of coordinates. 3, 0. And oops, negative 1, 0. Submit. Next. There we go. So now this is now our new graph, so we can ignore all the work that we've done up above. Find 2 points on the graph of the parabola other than the vertex and x-intercepts. So really what it wants you to do is just plug in numbers for x. The only difference is I cannot use the number 3, I cannot use the number negative 1, and I also can't use the vertex, which would be 1 and negative 4. So again, the vertex on this one is 1, negative 4. So I can't use those, but I can use any number other than 3, 1, and negative 1. It's completely up to you what you choose to use. Let's do 2. And then let's also do 5. Why not? I just am picking those. There is no rhyme or reason to them. They're just numbers that I decided I thought would be good. And they're not 3, negative 1, or 1. From here, again, we're just inputting things in. So I got 2 minus 1 squared minus 4. And down below I have 5 minus 1 squared minus 4. For this one, 2 minus 1 is 1 squared minus 4. 1 squared is 1 minus 4 is negative 3. So I have the coordinate 2, negative 3. And then for the one below it, 5 minus 1 is 4. 4 squared is 16 minus 4, which is 12. So now I have the coordinate 5, 12. They're going to ask you to type it in, so all you got to do is type it in. Remember, it includes sets of coordinates, so we can do 2, negative 3, and we can do 5, 12. Now that I got it, they want us to graph. We only need to graph 3 of these points, so let's graph. The vertex was at 1, negative 4, so we're going to just scoot this one over. Going to go 1, negative 4. Then we had one of our coordinates at 3, 0, so right 1, 2, 3, 0. And then the other one should be at negative 1, 0, negative 1, 0, submit. And there we go. So that was the short form, just, done in extra time. Let's do the long form. So the long form I say is long only because I have extra gubbins I have to do first. So let's write it out first. Negative x squared plus 4x minus 3. And we need to find the vertex. So in order to find the vertex, we're going to use x equals negative b over 2a. And in order to use this, I need to know what a, b, technically what c is, but a and b. A is going to be this thing right here, so negative 1. B is going to be the number in front of my x, so a positive 4. And if I really wanted to, I could say c equals a negative 3, though I don't need it for this formula. Take it, plug it in, see what happens. So x equals negative 4 over 2 times a. A happens to be negative 1. So we get negative 4 over negative 2. Negative divided by negative is a positive. 4 divided by 2 is 2. So I know that my x coordinate is 2. Downside, I need to know what my y coordinate is. Nice part is, all I need to do is take this x of 2 and throw it in my original equation. So we're going to say negative 2 squared plus 4 times 2 minus 3. 2 squared is 4 plus 2 times 4 is 8 minus 3. Negative 4 plus 8 minus 3. Negative 4 minus 3 is a negative 7 plus 8 would get us 1. Or negative 4 plus 8 is 4. 4 minus 3 is 1. So now I know that I have a coordinate, circle that a little bit better, at 2, 1. We'll go back here and type 1. Again, it wants to know how many x-intercepts I have. We get to solve. So we're just going to scoot down just a little bit more on this. Draw ourselves a line and then write negative x squared plus 4x minus 3 equals 0. Because since I'm trying to find the x-intercepts, it's got to equal 0. This is going to harken back to chapter 2. We need to factor. So let's factor this. In order to factor, we're going to use our first times last method to start with, just in case this works. So, whenever we do this, we are going to take our very first number, which is negative 1. We're going to multiply it by our very last number, which is negative 3. Negative 1 times negative 3 is a positive 3. And we're going to try to add to 4. When we do this, unfortunately, the only ones we get, 3 and 1. And what we're going to look for is, can I use 3 and 1 to make a 4? The answer is yes. I can take 3 plus 1, and I get 4. I didn't make any changes on the right side in order to get the 4, so I do not need to make any changes on the left side. We're going to go over here, and we're going to drop them in parentheses. We're going to say x plus 3, because this was a positive 3. And we're going to say x plus 1, because it's a positive 1, equals 0. We need to use this again. And so we're going to divide by my first number. And my first number, again, is this guy. So we're going to divide by negative 1. We're going to divide by negative 1. So x minus 3 and x minus 1. These are still in parentheses, and I want to finally know what x equals. So let's figure out what x equals. We're going to say that x will equal 3, and x will equal 1. Again, these are in parentheses. Whenever they come out of parentheses, we're going to change those signs. And so since I have actual x values, I know that I have an x-intercept at 3, 0, and at 1, 0. So, 2 of these. 3, 0, 1, 0. There you go. Find 2 points on the graph of the parabola other than the vertex and its x-intercepts. Again, you are just plugging in numbers into this equation. The only numbers that you cannot use are 1, 2, and 3. So, pick a new number other than 1, 2, or 3. What if we chose 0? Let's just write it out. And then let's pick something simple like 4. So, 0. Negative 0 squared plus 4 times 0 minus 3. 0 squared is 0, and if you make negative 0, you still get 0. Plus 4 times 0 is 0, minus 3, so we get negative 3, a coordinate of 0, negative 3. On this side, we're going to do 4, so negative 4 squared plus 4 times 4 minus 3. 4 squared is 16. 4 times 4 is 16. It then becomes a negative, so negative 16 plus 4 times 4, which is 16, minus 3. Negative 16 and a positive 16 makes 0, minus 3, so negative 3, giving us another coordinate at 4, negative 3. And again, you're just typing it in. So we have a first one at 0, negative 3, 4, negative 3. And then let's graph. Remember, we have that vertex all the way at the top, so we'll scroll up. The vertex that we found was this 2, 1, so right 2, up 1. Then we had coordinates at 3, 0. So 1, 2, 3, 0. And we also had one at 1, 0, which is what we have. If you don't want to use those, you can use the ones that we found down here. So 0, negative 3. So 0, 1, 2, 3. But they mean the same thing. Submit. And that should get you everything you need.